Welcome to Code with Vinay. In this video, we'll discuss how we can recursively raise one number to the power of another. We'll first discuss the usual method and then we'll improve it drastically using some class 8 level mathematics. In case you feel that you need to brush up your concepts of recursion, I've already made a video explaining the concept and implementing simple recursive methods. You can find the link of that video in the description. When computing a raised to the power of b, our assumption is that both a and b are integers and b is positive. We will be referring to a as base and b as exponent. The notation a to the power b means that the base is being multiplied by itself exponent number of times. For example, if base is 2 and exponent is 5, 2 will be multiplied by itself 5 times. However, this approach is not recursive in nature as we are talking of multiplication a certain number of times. Recursion means defining something in terms of itself. So in order to compute a to the power b, we need to express this in the form in which a to the power b is defined in terms of itself. Now, a to the power b can be expressed as a into a to the power b minus 1. Note that the second term, that is a to the power b minus 1, is in the form of base to the power of exponent, and this is ideal for recursive approach as we are defining power in terms of power. The next thing which we must look for is the base condition or the exit condition. Notice that with each recursive step, the value of the exponent will go down by 1 because we are saying b minus 1. There will come a time when the exponent reaches 0. We know that any number raised to the power 0 is 1, and hence our exit condition is if b is equals to 0. Let us dive into the coding part. So what we want to do is we want to define a function power. So public static int power, and this power function will take two arguments, the base and the exponent, both integers. And our exit condition was that if exponent equals 0, we'll return 1 because any number raised to the power 0 is 1. Otherwise, we'll return base multiplied by, and we'll call the recursive function now. So we'll say power into base comma exponent minus 1. So each time the exponent will be decreased by 1. A time will come when exponent will be equal to 0, then we'll return 1. This 1 will go to the previous call, it will get multiplied, and this will go back till the top. Let's also make a test case for the same. So we'll say system.out.println power, and we'll give a known case. Let's say 2, 5. 2, 5 is 2 2s are 4 2s are 8 2s are 16 2s are 32. So if our program is working, we should get 32. Let's run the code and see what happens. So if I run the code now, we are getting 32. Now let us visualize this code for better understanding. And I have made a small change over here. Instead of calculating 2 to the power 5, we are now calculating 2 to the power 3. So I have to save some time. And obviously 2 to the power 3 is 8. So if this code is working, we'll get 8. So let's begin the animation. So first the main will be initialized, and before that the array will be created for this for the command line argument, that is args. And then the function power will be called with the values 2 and 3. 2 is the base, 3 is the exponent. A stack frame is created, the values are transferred. Now the computer will check whether or not the exponent is equal to 0. It is not equal to 0. Now computer will attempt to multiply 2 by, and then it will put it on the stack, and then when we'll come back, we'll calculate the final answer. So right now we again call the function power. Again a stack frame is created. This time both base and exponent are 2. Again, we'll check whether 2 equals to 0 or not. 2 is not equal to 0. Again, we'll attempt to multiply 2 by the power of base into exponent minus 1. 2 minus 1 is equal to 1. Again, we'll call the function, this time with the value 2 and 1. Again, the new stack frame is created. And again, we'll check whether 1 is equal to 0 or not. 1 is not equal to 0. This call will be the last one now, the call which is about to be made. So 1 minus 1 is equal to 0. And the function will be called recursively one more time with the value 2, 0. And this time the exponent is equal to 0. So the value of 1 will be returned to the calling function, and then the multiplication will begin. So this 1 is returned, 2 into 1, that is 2. 2 is returned, and then again multiplied. 2 into 2, 4. 4 is returned, again multiplied, 4 2s are 8, and this 8 will be returned to the main method and it will be printed. So I hope that makes the things clear. Now let us talk about the improvement that I mentioned in the beginning of this video. A to the power b is equal to a to the power b divided by 2 into a to the power b divided by 2 when b is even. Notice that the term a to the power b by 2, that is this, is being repeated twice, and there is no need to calculate it twice. Now you might be wondering about the case when the exponent is odd, and the answer to that question is very simple. To cater to the odd exponent, we just need to multiply the result by the base or a, like this. And this takes care of both the scenarios, that is, when the exponent is odd and when the exponent is even. So let us now modify this code to make that optimization which we just discussed. So obviously the exit condition is not going to change, that will remain the same. What will happen now is that we'll first compute the repeating part. That is, we'll say int result is equal to, and the repeating part was par into base comma exponent divided by 2. So this is the part which repeats. So we'll compute it first and we'll store it in the variable result. And now we'll check whether or not the exponent is even. So we'll say that if exponent modulus 2 is equal to 0, that is, if it is even, we'll do something, and if it is not even, then we'll do something else. And if it is even, we decided that we'll say result is equal to result into result. And if it is odd, we have to just multiply this once more by the base. So I'll just copy this, paste it over here, and we'll say into base. I'll save the code and auto format it. And then finally, we have to return the result. So we'll say return result. Now this is going to drastically decrease the number of function calls required. So if we run the code again, the answer is not going to change, but we'll do it for verification. So let's run the code. And there we are again getting 32, but this time in considerably less time. In conclusion, the process of recursively raising one number to the power of another may seem daunting at first, but it's a crucial concept for any ISC computer science student. By following the basic method discussed in this video, you can elegantly calculate the power of any number. Furthermore, by optimizing the process using the knowledge of odd and even powers, you can significantly reduce the number of calculations required, making it quicker and more manageable. I hope that this video has helped you understand the concept of recursively raising one number to the power of another and has provided you with some valuable tools to help you tackle more complex mathematical problems. Always remember that with practice and determination, one can master any concept. Good luck and keep exploring.
Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. If you have any questions or suggestions for improvement, please don't hesitate to leave a comment or send me a message.